Hi everyone and welcome to my DConf Online 2021 talk called D for the 21st Century, Moving Fast Without Breaking Things. I was going to talk about the worst features ever implemented in a non-type programming language, but the more I thought about it, the more I realized I didn't really want to. So I pivoted to this instead, looking at these present and future, hopefully a bright one. So this is the 6-year-old slide in the sense that it keeps asking why. I'm not sure if it's actually at 6 years old that children do that. I don't have kids, so substitute that number for whatever you think is appropriate. But basically the slide is to tell you why and what we're going to talk about here today. I'm going to try to convince you why D has to change to stay relevant and why backwards compatibility is really important. What's currently stalling our progress on these issues? What are the problems we're having right now? Why a second version of Phobos would be a terrific idea, and why we may want to look at breaking language changes, and that might be a good idea, and what could we do with that, what we could explore. So why does D need to change, in my opinion? Well, other languages aren't standing still. We have competition, and a lot of them are closing the gap with regards to the things that D is good at. 10 years ago, C++11 got released, and that significantly closed the gap in terms of features. They added lambdas, they added type inference, all these kind of things that D had that C++ did not have. Well, they do now. So, Java, C Sharp, they keep releasing new versions too. And so they're not standing still. They are a competition. We do want to entice people to use D instead. And so we need to keep up with the times and keep up with them. The landscape as well in terms of what we can and can't do in programming keeps changing. 30 years ago, we had near and far pointers on DOS. Multi-threading was something nobody did. I mean, 10 years later, people would put that in a CV because it would be a differentiator. And now, basically everybody's expected to know what that means and how to deal with it. I know I have things like CUDA and heterogeneous computation and all sorts of things. So the hardware keeps improving and changing. Things keep changing. We need to keep up with that too. So we can't really afford to stay still. I think we need to also finish the features that we have right now. It's a common complaint that we have that, things aren't quite done and we keep adding things on top. But I think we need to draw a line in the sand and stop doing that and concentrate on the quality of what we have so that, we need to be confident that things are done for now and then we can move on to the next thing. And the thing is, we have an awesome language and we want to make it awesomer. And there's no way to do that unless we change. So we need to keep moving, we need to keep changing. On the other hand, we're looking towards the future, but we can't forget about our past because there is a lot of decode out there. I know that we like to say that most decode is yet to be written, but there is decode that has been written, and we don't want to break it. First of all, D is not a toy language. It is used in industry. I get paid to write D, for instance, and we don't want to cut into the bottom line of the companies that are using it. So we can't really break the code that's out there that's doing useful things. And even if we were just a hobbyist language, we don't really want to keep breaking people's code because they get very angry on GitHub. Anybody with a open source project there would know. And it's true that some people, even from industry, say that please break our code actually because this would make things better overall and we'll deal with it. But they're not going to agree with each other on what exactly we should break or not. People value different things, so different things are important. And I think that we really need to keep an eye on not breaking people's code, at least for no reason. I mean, we could make a decision at one point and what the trade-offs are, but I think the guiding principle should be to not break existing code. And backwards compatibility is really, really important because it decreases risk and ends up driving adoption. I've got here a few examples of projects I think did that really well and have stood the test of time. I mean, Windows, there's a guy that did a YouTube video a few years ago. I think he started with DOS and DOSBox and then installed Windows 3.1 and then kept upgrading up until Windows 7, if I'm not mistaken, maybe Windows 8. But this is a thing you can do, and it's nuts when you think about it, but it works. Yes, there's a lot of craft. Yes, there's a lot of things they have to keep carrying around because of that. But, it works, and they're still there. Intel with x86 as well. I mean, the computer I'm recording on this right now, when it booted up, it went into 16-bit real mode and then 32-bit protected mode and then into 64 bits because of backwards compatibility. But guess what? They're still around, we're still using them, and that's why. Intel themselves tried to break away from this mode with Itanium and failed spectacularly until AMD went and out Intel and created AMD 64, which was an actual success because it was backwards compatible. Could have added UTF-8 to this too because it's backwards compatible with ASCII. C++, I mentioned this in my DConf 2019 talk, because it was backwards compatible with C, there was no risk to adopting C++, right? They could just write a new file in C++, include the old headers, maybe an extern C here and there, things worked. So I think this is underrated, backwards compatibility. I think that it's really important, and because it just works, people mostly don't pay attention to it and they only really look at the craft that comes along with it. Stability is important. We want to give people the confidence that they can use that it will work. So again, we don't want to break the past. So I think we should learn from what happened to Python 3, even though they've been successful, the migration for the most part now. For a long time, there was a website called the Wall of Shame that listed all the packages on PyPI that were Python 2 only. And some of them are huge. I mean, Mercurial was Python 2 only for quite a while. I'm not entirely sure what happened there, especially since Git 1. But overall, I think backwards compatibility is important, and we don't want to break people's code, at least for no good reason. Now, what's still in progress right now? We have preview and reverts, which I think is a fantastic idea because we can play about with new features. People opt in with the preview switch. And then after a while, the idea is that we move it to the default and people can opt out with revert so that they won't be able to compile the code they had as is, at least with newer compilers, but they add the switch and things work. I think this is a great idea, but I also think it maybe hasn't worked as well as we would have hoped for because things seem to be stuck into this limbo in which they never leave preview. It is true we have a lot more preview switches than revert, but the thing is, that's actually a good thing. I mean, we don't want, well, more revert switches than preview for sure. We want to be able to experiment and only move things to revert when they're ready. The issue is, I think, that there's not enough things that have made it there from the ones we've implemented. Implementation issues have played a part in this by preventing us from moving to an opt-out model. So we really need to fix this. And I'm making an effort right now to make a preview DIP 1000 go into NAG mode, which is going to be something in between just preview and revert, in the sense that what would be errors with DIP 1000 turned on will become warnings instead, so that users will be nagged and hopefully nudged into the direction of making their code DIP 1000 compliant, even though their code will compile anyway. I think the nagging for a while will help us nudge people into a world which we can move to DIP 1000 by default. The reason for that is because this is strategically important, because then we can write safe code a lot easier. That's what's preventing most safe code from being written right now. So we need to do better on this. But it's a great idea. I think it's just the way we're dealing with it right now that could be improved maybe. SCD Experimental is right now where dreams go to die, pretty much, because nothing has ever made it out of there. I think it's a great idea as well, in theory. Let's put things in here that we can do breaking changes. We don't have the commitment we usually do, but things have been there for years, and I think we need to make a concerted effort to get them out of there, because to the extent of my knowledge, except for maybe the TypeCons one, there isn't anything there that hasn't been thoroughly tested and used. I have talked to Andre about allocators. There's a few things that he's concerned about, so we should address those post haste and then move that into SCD. I'm not sure if anybody has any problem with Logger as it is, so maybe we can move that too. I tried to move check tints and some people raised a few issues, so again, fix them, move it. Because the thing that will, again, give people confidence, even give the community confidence, inject a bit more energy, enthusiasm, that things aren't stalled, things aren't getting stuck in the mud. We are moving forward. This is going to be in the next version. And I think moving forward, probably, instead of sticking things in experimental to begin with, I think a lot more people should just put a package up on code.dlang.org. And that way it's a lot easier to iterate, it's a lot easier to change. You don't have to go through code review with everybody that's looking for notifications of Phobos. You know, you can use semver to break things from version 1 to 2 to 3, what have you, and only when we're confident with it, maybe it becomes a candidate to enter Phobos. I think this worked really well for SumType, for instance, that did exactly this. So I think this should probably be what we should encourage people to do, instead of making PRs to Phobos first, especially if it's something like, you know, it's a whole thing like SumType, it's a whole module, it's a whole package, it's got a lot of code in it. It should probably be vetted by the community that way first, because it's easier to do. And then we can look into, you know, possibly including it to Phobos. Another thing that's still in progress is Phobos itself, because it isn't versioned, which means a lot of things. Somebody even suggested we put Phobos as a package. I'm not suggesting necessarily we do this, but it is something to maybe be considered and talked about. And because it isn't versioned, we can't make breaking changes of any sort. And once it is in Phobos, any mistakes we make are set in stone. Now, sure, we're going to pay attention to the mistakes we've made, and we're going to learn. But we're going to make new mistakes. It's just a matter of fact. It's going to happen. It's like pretending that I'm not going to write any more bugs because I've written code for decades. It doesn't work like that. Once it's there, it's set in stone. We can't really change. And we can add, but we can't really subtract. We can't delete code. We can't delete functions after the fact, and we saw, you know, that maybe this wasn't the best thing. And some things sound like a good idea at the time, but then with usage and experience, just that maybe not. But the most part, I can't really change the behavior of the functions that are there either. So we end up with things like, again, in the adding not subtracting STD path, Walter added some non-allocating versions of the functions that already existed. And then you get things like absolute path and as absolute path, which is a bit of a goofy name, but it's better than absolute path 2. One allocates, the other doesn't, and this is a situation we find ourselves in. So this does also kind of stop us from moving forward. Again, we can add, but that creates that's got its own problems, etc., etc. So we've been talking about Phobos v2 recently. Like, let's get a version 2 of Phobos going in which we can get rid of all these problems. Let's move forward. Let's fix this. Let's have a solution. And the big one is, of course, no auto-decoding. I don't think there's anybody that's against this. I mean, this keeps coming up. It's one of those, sound like a good idea at the time. When I read Andrew's book, sounded like a good idea to me, but in practice turned out not to be. That alone would be enough of a reason to just remove auto-decoding, call it Phobos v2, and move on. I think that would already be a good release. I don't think we should be caught up in trying to make it too big of a release. We don't pay anything to add another number. Another thing that we were talked about is a range of chars of string. What does that mean? There's a lot of code in Phobos right now that is there to support different kinds of strings. So if you pass a string or a W string or a D string, everything kind of just works. But that's its own complexity, and it's probably not needed because at the end of the day, nearly all strings in D are UTF-8. And sometimes, sure, you're talking to the Windows API, you need a W string, but I think that the way we fix that is just by converting to and from at the edges, so at the seams, at the boundaries of that API. You need to call Win32, you convert whatever you have to W string, and then on the way back, you convert it again. We also want to improve included batteries. I mean, we've got parts of Phobos that were written a long time ago, and what was good then is not necessarily good now. Examples that keep coming up are XML and JSON. There's probably other ones as well. Socket comes to mind. And, we would want to have newer, more modern versions of this functionality in Phobos. And we could even replace it wholesale. Because the idea is to not abandon V1. That would always be available. But if you want to use the newer code, then you opt into V2 by using the correct import. And then a bigger focus on writing code that's safe in OGC. So we'll reduce the complaints about GC usage in the standard library, and no throw as well. The thing is, I don't think we should get stuck in only Phobos v2 because we really need to think about beyond that. Phobos vx, v3, v4, v5. So how do we manage that? Because it might become a burden in terms of maintenance. And so we'll be discussing how we manage that, and copy paste is a non-starter. I don't think we should do that. I mean, it's considered bad practice for a reason. Bug fixers have to go on all the copies. Things might drift apart, which is even worse when you have things that started out being identical but now aren't. We don't want that. So another thing we could do is just have branches for the old versions and cherry pick bug fixes. But that has its own problems because when you have 2 versions, that doesn't sound too bad. When you have 8 or 10, it starts getting really annoying. Doing that manually isn't particularly good. We could write a script, but the more the code gets changed, the more likely to be merge conflicts, and the human has to intervene and run tests for all of those versions too. So we're also talking about reusing code from older versions. So in a way that we have Phobos v2 is v1, but these things are slightly different. And how do we do that? Well, C Scheikhofer tried to do that with a template mixin, but there were issues with module scope symbols because there's a lot of parts there, because he was trying to remove auto decoding, and there were things that had a leading dot to pick up the symbols from the module scope, and with template mixins that doesn't quite work because the scope is now the template mixin. We could change the language to make that work. There's Andrew's idea from his Phobos PR that he posted to the forums recently for ideas. I think this is really good. I think it solves the problem with reusing things from here and there. The issue there, of course, is there's also some change that needs to support it because the documentation generation isn't going to work because the code isn't quite there. It's coming from somewhere else, which is a problem with both of these approaches. The code gets harder to navigate because the implementation isn't where you thought it was. You have to jump from something else and then it gets instantiated in V1, V2, Vn. And another way we could do this is publicly importing all the Phobos. So I would start algorithm v2. I would publicly import everything from algorithm v1 and then add a few things if they have the same name. Things just kind of work. But Andrew brought up a problem, which is imagine v2 wants to change its input range, but the algorithms v1 are perfectly okay with this change. So how do we look up its input range of v2 but get the implementation for v1? Currently that wouldn't work that would also require slight language changes going forward. Now, on the other hand, how much code do we actually want to reuse? Because a lot of this will be just new code. You know, it's a spectrum. On the one hand, you have things like algorithm, which is unlikely to change because these are, very basic fundamentals. So we do want to reuse that code, and we don't want to be copying it around. On the other, end of the spectrum, we have things like XML and JSON that we just want to replace wholesale. And there's going to be things in the middle that probably depend on algorithm, depend on SCD Uni or what have you. And I think it's going to be hard for us to say right now without auditing the code and basically trying to do this and finding out as we go along, and maybe even writing code for reusability in a future version, having that in mind. So there's definitely going to be some issues, maybe some problems, some challenges, but I think this is worth doing, worth thinking about, worth fixing so that we can move forward. Again, the idea is that the old versions are always going to be available, code doesn't break, you have to opt into the new version, etc., etc. But that's for library code. What about the language itself? So we're kind of stuck with the language, right? Because we can't really break things. Again, we've talked about this a lot. And I think maybe we should engage in the best kind of flattery and just copy the idea from somewhere else. Now, Rust has this thing called editions. They've got the 2015 and 2018 editions so far. And there's a C++ proposal to introduce it there called Epochs, which I think was the original name of this Rust feature. And the idea is that you can change the language and then release a new edition of it, revised, and it can coexist with the old version. And it's going to be on a module per module basis. So in the C++ proposal even, they said they had to wait for C++ 20 because with headers this wouldn't work. You need modules, you need proper modularization. So you do it per module. It's opt-in, so you have to opt into the new edition. So by default, it goes to the whatever the first one was. And you want to be able to interoperate between different editions, so different modules can be compiled in different language versions, and they can still talk to each other, and that's okay. So, there's issues here with mangling, but I think that can be solved because if you import a module that's from an old edition, then you use whatever its rules are, and therefore, both modules agree on what the mangling is, if there's scope or not, what that means, etc. In Rust, they have an automated migration tool that doesn't always work, but at least does some of the work for you. I think this is a nice to have. I think the most important thing here is to not break old code and allow us or any other project to migrate module per module to go to the new version and get all of the good things, participate in all of the things it has. I don't know if there's going to be any front-end implementation issues with DMD. Because what we want here is for the code, no matter which edition it's written in, to lower to the same AST. So at the end of the day, after it gets parsed, and maybe during semantic analysis, I'm not sure exactly when, things will kind of look the same no matter what the input actually was. Since it wasn't designed with this in mind, will we have issues? I don't know. But then if we do, it's a question of refactoring it so that we don't, and then moving forward. This is ambitious. This might be contentious. Let me know what you think. But I think this is a really good idea so that we could be free of the shackles of the past and be able to make breaking changes. And in that spirit, the rest of the talk is really going to be examples of what kind of fixes that we could make. I'm not necessarily advocating for any of these, but let's dream big. Let's see what we can do with this, and let's imagine. So what is the kind of thing we can do? Well, one possible fix is make const by default, because I think that mutability by default is a massive mistake. And the reason for that is that mutability couples values with time. You turn every variable name, every alias, into a impure function that returns or might return a different value every time you call it. And so you don't know if it's going to return to you. And that makes code a lot harder to reason about. This gets even worse if the variable is visible to other modules because it's a module scope immutable. And now you don't know who's changing what when. Add thread to that, it's another nightmare on top of it. And defaults are important, as I mentioned last year, and it's a bad default when member functions needs to have const added to them. Because if a programmer forgets to, you can't have const objects, you can't even use that struct or that class. And I currently work in a code base in which toString isn't const, not because of any good reason, but just because nobody wrote it there. And then of course that means a bunch of downstream things aren't const either, and then it's a lot harder to do it after the fact. I think that obviously mutability is something that you should be able to opt into. It is a lot easier to write certain classes of algorithms. It is a lot easier to read code sometimes when you're able to mutate. But I don't think it should be the default. I think it's something you should be opting into, and you should be able to say to the compiler, look, this member function will mutate the this reference. And why const instead of immutable? Well, because immutable is too restrictive. If you're assigned to immutable from something that has the directions in it, that's not going to compile. You're going to have to either copy everything or something else. Const is, I think, a good default for this. Again, I'm advocating we necessarily do this, but this is something we could do, and in this case, I probably would advocate for it. But it requires language changes, some way to say that things are mutable instead of the default. Another possible fix is, I mean, this comes up all the time. The attributes here, it doesn't taste good. It doesn't look good. It could put people off the language. It is a lot of work. So maybe we could fix this with a new addition. Maybe we could, make safe the default this way. I can see this working really well with different additions. Like you didn't put anything on it. Well, it's system, new addition. Well, it's safe. And this is a question of, after lowering again, things should just work. To make no throw the default would require some sort of alternate error handling mechanism. So we'd have to first come up with that and then make that change before we could even think of no throw being the default. But it's a thing we could do. Maybe we can introduce attribute negation, which is something that keeps coming up as a request. I put pure colon and then I want to negate pure for this one function. Weirdly enough, this only really works for safe. If you put safe colon, you can then have a function that's trusted or system, and that's fine. It kind of overrides the module thing, but you can't really do it for the other ones. And then there's this thing that we have that, some attributes have at, some don't. It's kind of arbitrary. So we could maybe fix that in a new edition. And we can have namespace attributes, because as Jacob Colbert brought up once, that do we need to compiler, recognize attributes? Because we already have UDAs. So for instance, at safe, you could have an enum safe in object.d, and at safe would be recognized everywhere. Since that module is imported implicitly, it would just work. And if there's any clash, because the whole point of having attributes instead of keywords is that people could use the words that are keywords. There's no reserved words for that anymore. We have the module system. So if there's a safe somewhere else, you could have object.safe and my module.safe. So this is one thing we could do with it. Another thing that we've been talking about is proto-object. Well, why we're doing this? Because to fix the problems we have with objects, we can't really change it, so we'll put something higher up that object inherits from, which is a complication in and of itself. It's harder to explain to people coming from the language. Why do we have to base objects? Maybe we don't need to. Maybe in a new edition, we just change what object means. And basically means the same as proto-object, and we introduce this in for like older editions, that will be a thing. And then we could get rid of the monitor, kind of improve layout, and by that I mean binary layout, because in our code base we're using external C++ classes explicitly for the layout, not because of C++ interop, and that's not what that was meant for. And then we can have the problems with attributes in object.d, because all those functions that were there were preceded safe and pure, for instance, so we can possibly fix that. Class references. I think it's a good thing that if you have a type that's supposed to be engaged in OOP, that it's only ever a pointer, because you don't slice objects. That is a fantastic idea. I'm not convinced, however, of it automatically being a reference if it's a class or interface, because in generic code, I've had to write, distinguish between the two of them more times than I can count. And what's bad for generic code is, in my opinion, usually just bad in general. I think what should probably have, again, if I could do everything from scratch, is mandate that class and interface types are always T star. And if they're not, that doesn't compile, but at least it's explicit, and you don't have to have, these weird workarounds that exist right now. That's another thing we could do. And, we could introduce another error handling mechanism. I know Walter's trying to move away from exceptions because they're costly. And then there's so many things we could do, some types of pattern matching in the language. Railway-oriented programming, which is basically fancy word for monads, which is a fancy name for other things anyway. You can look up what that means, or we could also go maybe the route that there's a proposal in C++ to do zero overhead deterministic exceptions, in which throw doesn't really throw, it just returns a result value. And in the spirit of C++, I came up with an acronym for this called ZODE, because C++ is the gift that keeps on giving when it comes to ridiculously bad acronyms. So anyone? No. So, to summarize, and all these opinions of my own, which means, it's like the leadership thinks, no, I'm just think this is what I think, and let's see what we can agree with the community as well, with Walter, with everybody else. Let's have a conversation about this. But this is where I'm coming from. These are my ideas. I don't think we can afford to not change. We have to keep moving forward. We have to try to do our best to get new users in and not lose the ones we have. I think we should make a concerted effort to finish anything that we've already put out right now, fix all the bugs, give people confidence that things work and they can go forward and depend on it before we start adding new ones. And that includes the stuff I've been talking about today. DIP 1000 is incredibly important. We should really get that over the finish line properly, confidently, and take it from there. I think we need to wait to embrace the future without breaking the past, because otherwise we're going to get ossified, we're going to get stuck in the mud, and things are going to be a lot harder to do. And I think the worst a code base can do to me personally, to offend me, is make it hard for me to change it, which is why I keep harping on about tests. I don't really like tests as much. I like what they enable. I don't like going to the gym either. Just don't like the alternative. I think we need to also need more proven preview switches to revert, or if they don't work, just get rid of them. Deprecate them, not get rid of them immediately because somebody out there is using them. But make a decision, not keep them stuck in limbo. And likewise, same with experimental. Let's not have limbo. That reduces, energy and passion. We need to bring that back, I think, and just move forward. Finalize shared. I mean, people keep bringing this up, but I'm not entirely sure what they mean by that, because I think shared does most of what it's supposed to do, which is disallow people doing things with shared pointers and references that they shouldn't be doing, or shared values that have pointers inside of them, so in directions. I think with that preview switch that we have for that, we're pretty much there. Anything else, I think, should be a library solution on top. I wrote a library called Fearless. Maybe that should be the basis for, using shared values, so that right now, otherwise you have to manually cast and lock a mutex or something like that, make sure that you're doing it right. I think that a library can, like the one I wrote, provide a safe interface to something that is inherently unsafe by not letting you access the value without locking a mutex that's within the wrapper. So, let me know what you think about this. I mean, I'm not entirely sure what people expect with finalized shared. I'm kind of happy with it the way it is right now, but reasonable people may disagree. And, a call to action here. Like, we really need help with all of these things, especially with fixing bugs and things like that, because I think I spent way too much time trying to fix the template mission bugs and not getting anywhere. And I'm not the best person to do it. So let's leverage the skills that we have in the community, and the best people to do it should work. So if there's something that any about this like annoys you, please submit PRs, fix bugs. Let's move things forward. Let's all work together towards this common goal. And having said that, right after this ends, feel free to ask any questions. Hope you enjoyed that talk. That's it for me. Thanks.